Okay, so I think that we can start. So first of all, dzień dobry I witam na mojej sesji about user-defined functions. So this is the only thing I can speak in Polish, but I hope next year I will have a few more words for you. So I hope you enjoyed so far the conference, and I'm really happy to present here for another year. I wish it could be on-prem, but definitely I think that we will have this. Oops, come on, that looks a little... I have some problems with my avatar, but don't worry about it. So I hope that you can see the screen sharing, what I'm doing. You will see a presentation, slide deck, and I'm talking about user-defined functions here. The evolution of user-defined functions from 2000 up to 2019. So first of all, a big thank you to all the sponsors of this great conference. And I think that you all know that without these partners who are supporting these kind of conferences won't happen. Okay, so now we can start. This is about me, very short. You see the commercial on the left side, and on the right side, there is the most important thing. That is my email address. Feel free to drop me an email whenever you have any questions concerning SQL Server, the engine, function, everything about it. I promise to answer you every single question. This is our agenda for the next 60 minutes. Basically, I want to have you all on one level. I would expect that you all are developers and you are familiar with user-defined functions. But what I want to do is I want to show you a few specifics about the different types of user-defined functions. And then I'm showing you the limitations of user-defined functions as you maybe know from further developments. So afterwards, when we have defined the different types of user-defined functions, I want to show you the problems. And the good thing is, if you're working with SQL Server 2017 or 2019, I promise you will have really great improvements about user-defined functions. I think that you will love them. Let me go to Avatar. Can you please raise your hand? Do you see now something here? What's going on? Oh, yay! Here, perfect. Okay, then we can start.
Applause for Owen and support F4.
Yeah. I love these challenges, you know? Okay, good. Okay, so the agenda is clear. I do not have to repeat it. I want to show you the basics, and then we go to the problems, and then I show you the optimizations we had in SQL Server 2017 and 2019. I think all of you who are sitting here in this conference, you are all developers. So, and I would assume that most of you were using user-defined functions since it was available first in SQL Server 2000. I was a developer. I did it with a real enthusiasm because I thought, my God, that's so cool. Have user-defined functions for everything recurring activities. That was so cool. The problem with the functions I was not aware of. And so I ran into lots of problems since it started with SQL 2000. The cool thing is that they can perform actions such as complex calculations, and they can return results or tables. And for me, the primarily reason to use user-defined functions was the so-called reusability of code. And that was a so fantastic feature here for me. They allow modular programming. That's cool. They can allow faster. You see that it's bold, yeah? They can allow faster execution. It does not mean it will. And this is the pitfall, the first pitfall where I was falling in. They can reduce network traffic, but you see, this is more a commercial statement from the Microsoft websites instead of real life. Yeah, so this can be true if you just only, for example, filter for one single row. Then I would say, could be good, but it depends always on the way how you develop your user-defined functions. User-defined functions have some limitations and some restrictions. I don't want to read them all down. You can follow up with this when you go through the presentation. But there is one important thing what I want to mention, that is that you cannot not have multiple result sets. So a user-defined function can only return a Scala function, Scala value, or one row set. That's the maximum what you can use. And another problem with user-defined functions is that you cannot use dynamic SQL or temporary tables. But instead of temporary tables, you have the ability to use table variables, but they can be a nightmare. And that's what I want to show you when I show you the drawbacks. And it's clear that you cannot use XML, you cannot use set statements because they would change the context. So what type of user-defined functions do we have? The good thing is we just only have two of them. The first is the Scala function. Scala function returns just only one predefined data value back to the client. So this is, as in typical languages too, that you create a function which returns one value back. For example, what is the number of orders, number of orders per customer, something like this. And on the other hand, we have the so-called table-valued functions. Table-valued functions return row sets back, and you have two kinds of these table-valued functions. The first one is the multi-line table-valued functions, and the second one is the inline table-valued function. And this I can say now at the beginning is whenever you are thinking about table-valued functions, there is one thing I could strongly recommend, and this is that you mostly should try to avoid multi-line functions, but you should use inline functions. Okay, I see it here. That's perfect. Okay, Isaac had the same problem as me. Good. So, paradigm shift with SQL 2017. So, to be honest, SQL Server was, Microsoft was definitely aware of the problems occurred with user-defined functions. So the problem is that they started with SQL Server 2017 to improve. To be honest, they started with 2014 with the so-called estimates. I come later on in the demos to this. And this was one first challenge, but one first optimization. But to be honest, it was not as good as most of us have expected. So we had a minor improvement, but that was not okay. So with 2017, the first real super break was coming. And I will explain it when I show you some extended events. Suddenly, they were breaking the pipeline between the query optimization and the execution. And exactly that was the silver bullet, which was giving way better improvements to the SQL Server user-defined functions. The other thing, what you may know, is batch mode, adaptive join operators came into the game. And with 2019, they made suddenly the user-defined Scala function, they made a big improvement with this. And I will show you what it is. Table variable, deferred compilation, all this kind of stuff. That was improvements with the latest versions of SQL Server, which from my point of view, is it worth to switch from older versions to at least 2017 or better to 2019? So now I can see this, you know what I'm doing? I'm turning around because then I can see it here. Yeah. Just a second, please. Go into you know what I'm doing? I'm going into the audience. That's better. So then I speak to you.
You can zoom the screen from the stage already, so.
So now I see it the same as you do. And when I see that it freezes, then I know that I need urgent help from you. Okay, so there is one problem with the Scala function. The Scala functions, when you use them as an output in a select statement, that can cause quite heavy CPU and I/O consumption. The problem is here that then SQL Server will execute the Scala function for every single row which you will return to the customer, to the client. So, so This is the key point here, problems. Iterative invocation. So UDFs are invoked in in an iterative manner, so for every single row. Lack of costing. This is really a big problem. During the optimization phase, the costs for so-called relational operators are calculated. I will show this in the demo, which is going after this slide here. So while Scala operators are not. So that means when you are using functions in your SQL statement, they will always be mentioned as 0% of costs. And that makes it so incredible to estimate what are the real costs from your SQL statement. Interpreted executions, I evaluate it as a batch of statements. So they get executed statement by statement. And I will prove it by evidence with the demo that this will happen. And the last thing, and that's the reason why it's so big and so bold and red, serial execution. That means when you have a SQL statement which will normally run in parallel or has the option to run in parallel, it won't work when you have a Scala function in it. And let me show you in a demo how this will work. So check. It's coming a little bit later, but now here we are. I think that you all can see this here. And let's go to the first demo here. I have prepared the first query that I have created my demo environment. So I think you all can read this. And I go now step by step through it. One thing to mention before, I'm working on a SQL Server 2019. So whenever I do a flip back to older versions, I set the database compatibility level back. So here we are now in the mode of 2014. So, okay, go for it. And what I want to do is I want to make sure that the new brand new features since 2017 get not executed, so I switch it off. And here is my preparation. What I'm doing is hopefully they are in, and I think so. Okay, they're executing. Yeah. Okay. So I have two tables here, and now I have this query. Just let's first of all think about what's going on in this query here. The query is a very simple thing where I'm using, where I want to have the name and the ID of my customer with the ID number 10, and I want to have the number of orders for 2019. So this is the query I want to run. Yeah, and I see that my storage query is running. This one is done, but he's fighting with the customer orders. Give it a few seconds, please. And while it is running above, let me show you or let me explain to you the next steps in this demo. What you can see here is that I, as a developer, wants now to have a function which saves me time by typing in this statement with the select count big, and therefore I will create a user-defined function which returns a big int. So you can see this here. And this function, I have to hand over the customer ID and the year where I want to have the orders from. And then my query returns the number of rows or the number of orders for a given time period. So I give the order year, and then I add 1 year that I can say this is for example, 2019. Here is my first query. And this is without a function. And I do this with an execution plan. This is just only one row. And you can see here, come on. And my CPU is burning down my desk here. So the number 10, we have 9 orders per year. And when I go to the execution plan, you see here, and this is I need to mention, this is done not by accident. I'm using heaps because I want to have a little workload. And you can see here that SQL Server now is going in parallel. We are going through the customers. We are looking for the predicate 10 for the customer 10. And then comes the important point. Here is my customer orders. And now we scan through the customer orders, make the aggregation, so the count big, and we transfer, we convert it, and then we get this one single row back. The good thing here is that everything is running in parallel, so all 4 cores are used. Good. Now, we as developer decide to have a function around this. Let me see when it will refresh. I don't see that the screen get refreshed. No. Okay, now it is. And okay, so now I create this function for it, and I run this query again. And what I'm doing now here is the following. I want to know, is the Scala function approach faster than the one with the set-based operation where I use my my cross-apply? So what I'm doing is I run both here and I give only 5 rows back. So just only for 5 accounts, for 5 customers. And let's see how long it will take. The first one will use the function, while the second one will use the cross-apply operator, which, oops, don't see my, okay, yeah. So here they are. Here is the number 1, here is the number 2. And here is the first pitfall. When you're investigating the execution plans and only take care of the execution plans, what will be your first thing, what comes into your mind? You will say, ha! The Scala function is way faster than the second one because it is estimated that it just only uses 1% of the whole batch instead of the 99 of the second one. And the first one is going in single threaded, so it just only consumes one CPU, while the second one is consuming a huge amount. It's taking all my CPUs. But this is just only one side of the medal. We need to look into the statistics. Can you all hear me? You raise your hand that I can see that you can hear me? Okay, good. Okay, I'm really sorry about this. Sorry, but I hope that it will work now. Okay, go back to this. So, you got 50 users and I cannot present. Nightmare. So here is my Scala function. Look to this result, and you can see here, and that is the point why SQL Server has estimated that's only 1% of the whole total cost. That SQL Server only considers the customer's table to get scanned. So SQL Server does not reflect that the function was producing I/O in the same time, in the same way. And here you can see the set-based operation, and here you can see that the customer orders get used. So we have 5 times working in with a parallel process. We're going into the customer orders, and we were reading in total 70,000 IOs. So another very impressive, a really impressive way is look to the CPU time for the Scala function. Just only the CPU time. It's 6 seconds pure CPU, and when you look to the set-based operation, it's just only 25% of that. So the execution plan, which is based on I/O, say, well, with the function, it was way faster than it is with the set-based operation, but the statistics, especially the time statistics, will say, no, that's definitely not true. So whenever you're thinking about this, it is always that you should consider to use set-based operations. So now, what I definitely skip this with 100 rows. I will never come back. So what will I do then? Here you see that I have a stored procedure. This is all prepared, which creates an X event. And I want to show you why this is so incredibly expensive and what is the reason behind that we do not, that SQL Server cannot cover this. As I said, the biggest problem here is that compute scalar. This is not a set-based operator, and therefore SQL Server do not consider this as a cost factor in the execution plan. And here, when we go into the, now that we want to see the truth behind, I create an X event, and this X event will tracking the execution of a Scala function. I go into the live data. I do not save the data. And here, come on, we go for this. And now run this query. Yeah, back, here we are. So here is my query. And I just only go for one single row. And I want to have the number of orders for the customer with the ID number 10 for 2019. So it was running in 2 seconds. And now look to this. What you can see here, and this is really, really interesting. This is absolutely valued to know. Look what SQL Server is doing. We just only have one row back. And look to the order of the execution. SQL Server was once starting the execution of the function. And after this, we came back with a complete statement. To make it a little bit more clear, do it this way. I just go for 5 rows. So now I have 5 customers, and now I need to go 5 times. For 5 customers, I need to go into the customer orders table. I need to call the Scala function. And this is what happens. And that's what the SQL Server execution plan do not cover here. So what you see is that we go for customer number 1, customer number 2, 3, 4, 5, and then the statement is completed. And this is what you don't see in the execution plan, and this is what you unfortunately don't see in the statistics output when we are talking about I/O, and this is only based on I/O. So we do a full scan 5 times through the customer orders table. However, we look now for the next part, how we can improve this. This one here, to be honest, I don't want to run this for one single reason. I see this kind of development so often in codes, and the developers did not know why this query is so incredibly slow. Let me show you the so-called estimated execution plan, and you will see immediately what the problem is. Here you see my query. This is the original query. Select from where, and here is the function which I have created, and you see that it's doing a table scan. So we go through the table, and we are going through 3 million rows. And now comes the problem. Let me show you the query again, that you can understand what's going on. This is the query where I say, please give me everything where the customer is number 10, and I want to have from every customer I found, only these customers which have more than 5 orders in 2019. And here is the nightmare. I cannot show this in the live data because it will flood my screen here. Here is my table scan. So we go and look to the order here. We go through 75,000 rows. So 75,000 rows are walking over to the filter operator. And at that point, we are now going with the 75,000 orders and we are proving the predicate. And look to this predicate. We say, well, there must be a customer ID which is smaller or equal to 10, and now you see that it will invoke the. Where is my screen? Come back. Yeah. So here you can see that now SQL Server will, that's the reason why I don't execute this, will now 75,000 times execute my function. And I could finish now my session when I start this query and say, come back in approximately 1 hour. And then I show you the results. But this is not helpful here. I will skip this. So Microsoft is definitely aware of this problem. So they made a few improvements. And these improvements with Scala functions in 29 is the possibility to use use the Scala function as part of the set-based operation. And this is called user-defined function inlining. So what SQL Server now will do, SQL Server will check whether the code inside the Scala function can be applied as a regular set-based operation to the query. So this does mean I start this, go for it, okay, and you see this original query. You see that I'm using here an apply. By the way, that could be an inner join with a subselect. It's exactly the same so far. And when you see this query, SQL Server can use this one as a set-based operation in the query in the same way as when we do a join. So the SQL Server has some limitations on a Scala function when it can come to so-called inlining. So that does mean, is this function, what I'm using, is it possible to use this as an inline function? And you can see here, yes, it is inlineable. Okay, that does mean that now SQL Server tries to put the part of the function as a set-based operation to it. Therefore, I recreate my X event for Scala functions. I do not implement the execution plan. That takes, unfortunately, with the CPU problems here, way too long. So let me show you the live data. Here we are, and now we can play around. Here comes the first. That's the way how SQL Server is working with Scala functions before 2019. I run this query, walk around, and it takes, you see that it takes a while, 5, 6, 7, 8 seconds. And when I look to this, you can see here, once executed, second time, third time, come on, give me more, yes. 5 times executed, and then the query is finished. Now, since we are now in SQL 2019, I am using exactly the same one here. So that does mean that now I run this query. You see here my function in the output, so it gets invoked every single time. But see what SQL Server now is doing. It runs faster, must run faster, definitely. Go for it. And it's, come on, you give everything. Yes. Here, stop, no, not yet. 1, 2, 3, 4, 5. It's executing. Come on. Dang. You see, it never comes back. Oops. What is the problem here? The problem is that this here is not a problem of the inlining. This is a problem because I do not have any indexes here. So what I do now is I try to speed it up. I use indexes here because the problem here is that SQL Server always now tries to scan the customer orders table. There are 3 million rows in it. That takes way too long. And you can see here, let me check. Yeah, this is my statement. Come on, create unique index. Shit, yeah, it takes a little bit of time. Confusing. So now, before and after, when the indexes are finished, clear the data here. Come on. So yeah, I wish I could be on Prime, because then in the meantime I would do a little dance for you, or singing, or telling a joke, or whatever. And the good thing would be that the execution would be way faster than it is actually. Oh, come on, go for it, you got it. So, however, in the meantime, I go to another thing. I will come back later on to this, okay? So, 2019 brought so-called automatic inlining. What is the basic requirement for this? Yeah, thank you, Hugo, thank you so much. Yeah. The basic requirement for using automatic inlining is that it has to be, there must be a query with a single or multiple select statements. If, then else can be used. And it must be a single or multiple return statements inside. There are unfortunately some restrictions, but for the one side, I would say, yes, restrictions, always restrictions. But on the other hand, I would say, yeah, that's okay. You cannot use intrinsic functions. So if you're using get date, new sequential ID, so something which is not predictable, then SQL Server cannot use automatic inlining. You're not allowed to reference table variables. So, for example, you have a Scala function where you push some data into a table variable which you use, then it cannot be an inlining, automatic inlining. Same with an order by, and with it's not allowed to use references to user-defined data types. I'm not a fan of user-defined data types, but I know that many are using this. And okay, no references to CTEs. So hopefully this will be done. Yay, it's done. It's so good. It was only taking 1.5 minutes for a process which normally takes 5 seconds. So cool. I love our talent, by the way. So now the first thing. I first of all clear here everything. Come on, clear data. And this is the behavior before. You can see that it goes incredibly fast. It's incredible. Okay, not incredible. 100 rows, get back, and look to the nightmare in the execution here. And you can see that SQL Server now is running 100 times this select count big before it finishes my original query. And that is because it gets invoked every single time when a new row gets fetched from the data. And with the new cool thing, when I now enable it, it's automatically in SQL 2019. That is the cool thing. So you don't have to change anything. When I run this, go for it, and it's done. And it's less than a second. And with this background tasks, it is it's a cool value. And here comes the point. You see here that SQL Server now is executing the complete statement as one. It does not invoke every single time the function. It's using it as a part of the row set. And let me see here. Let me run this query again now with an execution plan on. And here you can see what's going on. Now SQL Server has taken the function as part of the execution plan. Here's my customer orders. We build an aggregation that the count big. Then we come back here with the nested loop going for the 5 rows or 100 rows we found, getting back the aggregated values. So there is nothing more. The behavior before was, yeah, give me 1 row, give me 1 row, give me 1 row. And SQL Server did not consider it as an operator, as a physical operator in the execution plan, but as a compute scalar, which is 0 cost. So that is, from my understanding, a big improvement if you're dealing with SQL 2019. Automatic inlining can be disabled. I would not recommend this, but it's possible. You can do this by database code configuration or set the compatibility level to a former level, or with the use hint. So when I must disable it, I would recommend to use the use hint. Multi-statement table functions, I go quite fast about it. We got these basics. What is a multi-statement table function? Multi-statement does mean that we do not return immediately a row set back, but we store it in between, here in this example, in a table variable, which then gets returned from the function. There is one big issue with this kind of statements. The problem is that multi-statements have problems with estimates. If you're working with SQL Server prior to 2014, the estimated row size was always 1. So whatever, how much rows you want to get back, it's completely independent. Always, SQL Server was always thinking, there's just one row getting back. So then the team from Microsoft were sitting together and said, hey, what can we do to make the users happy? And then someone said, well, let the estimate be 100 and all problems are gone. But the problem is it didn't work. So 100, that's okay. That maybe was a good idea back in the 90s when we had small databases. But nowadays we are not dealing with 1,000 rows or with 100,000 rows. So nowadays, when I look to databases on a customer side, I would say the average is, at least for an org table, I would say 10 to 50 million rows. So the estimates of 100 could be a big problem, especially when you're dealing with so-called stop operators in the execution plan. A hash match operator or a sort operator, which requires memory. So the memory allocation does not fit from the estimated, because SQL Server is calculating based on the estimates. And then we come to reality, and then we see, oh my goodness, there are hundreds more or thousands more of rows coming back. Let me show you how this problem can affect you. So here we are in I can close this one, and we go to the multi-line table value functions. How it was in 2000 back, and nowadays in 2019. So I have my custom orders. I don't rebuild this. That takes too much time. And here is a very primitive way of a multi-line function. You see, very easy. I declare my output, which is a table variable. This is the structure of my table. And then I only say, give me n rows and push them into this table and return. So very easy. It's absolutely okay to demonstrate the problem we will have with these multi-line functions. By the way, and that is because we are a little bit lack of time, is with inline functions, just only return a select statement. You don't have any of these problems. That's to mention here. So behavior up to SQL Server 2012. This is what SQL Server 2012 was thinking when we wanted to return 10,000 rows. So get the 10,000. Oh, sorry. Yeah, I need to go into the database. That's clear. DB, and we are now starting. This is the first one. Oh, gosh. Yeah. Oh, good. Now I have one more object in master. I love this. My master would look like a playroom from a 5-year-old. So this is in 2012. So SQL Server is running. We get 10,000 rows back. And keep in mind that I have an order by in it. So here's my execution plan. And you can see that we are now facing a sort spill. And this sort spill is coming because of one simple reason. Look to this here. The clustered index scan was expecting one row back to return only one row. Just one row, that means that SQL Server here will say, well, come on, baby. For only one row, I give you 1 megabyte of RAM for the sort operation. And then comes reality. Instead of 1, there were 10,000 coming back. That's the same as when you go with a knife to shooting. And that happens here in SQL Server in the same way. So that was a problem up to SQL Server 2012. And then the team were sitting together and say, hey, let's make SQL Server great again and do some improvements in multi-line functions. We are back with 10,000 and we see, oops, sort operator is spilling to 10db. The only thing what I have changed is, look to this, SQL Server was thinking that we get 100 rows back. So only with just 100 rows instead of 10,000. It's a little bit of difference here. And therefore, with this 100 rows, we were thinking, 1 megabyte of RAM for the sort operation will be enough. And this is a problem. This is one of the biggest problems we have. So now, when we come to SQL Server 2017, you can look to this 10,000, go into the execution plan, and problem is gone. Oops. I think this is really a cool improvement. And when I look to the estimates and I look to the actual number, I see, well, wow, they are fitting together. And that is a really cool feature because now SQL Server can estimate or grant, can make the more efficient memory grant. So this is the technique, what you can see in 2017. For you as a developer, and I hope it is not important that it works, but you want to understand why this will work. And this is what I want to show you. It's called interleaved execution. It might be a little bit complicated, but I promise it isn't when you see how the mechanism is working inside. So what I'm doing here is, first of all, I set my database to the compatibility level 150. I just want to make sure that everything works. And I set the interleaved execution of table valued functions to on, just only for make sure that everything is working fine. Then, to prove it by evidence, what's going on behind the scene, I have an X event called track multiline functions. So here, I just only want to make sure that I do this again. I create this again, and now with a show plan, and that does mean that I want to show you the execution plan when it starts. So here comes, let me check this. This is the query. So I'm clearing the procedure cache. Go for it. Okay, cache miss, fine. And here comes the first query where I say, this is the behavior of the system as it is before 2017. So I disable it. And here comes the query. I want to have the customers from the last 10, from any 10,000 orders with the execution plan. Go for it. Here we are, and it takes a while, and you see that there is an order by, and here is my execution plan. Go for it. You see that SQL Server is estimating 100 rows. We go into a nested loop for 100 rows. Maybe a hash operator would be better. However, it is working. And now look what SQL Server has recorded here. Let me show this. This is something I need to get ad hoc cache. One moment, do it again. Can be because of the cleared cache. So now you see here that SQL Server, now perfect. Look to this. This is really important to understand what's going on. Before 2017, a table valued function was always be compiled before the whole statement got compiled. And you can see perfectly here. You see, here is my temp function, so that the object type, that is something what happened with my function. And here you can see that the statement itself here now is completed. This is the original query. So what happens here? So SQL Server now is evaluating the table valued function, and look to the post, let me see, unfortunately only the post execution plan, but there is a post compilation plan. Unfortunately, it doesn't show it here for the problem with this CPU. Look to this, and you can see here, at that time, SQL Server knows that there will be 10,000, but the problem with this is that before, at the compile time, and that was a feature which was hard-coded in SQL Server was thinking, well, just only 100 rows back. So after this function has been built, now we go to the execution plan. Here you can see that at the compile time, not at the execution time, SQL Server was estimating 100 rows. The biggest, and that is perfectly shown here, the biggest problem we have with this kind of execution is that the function gets executed or gets compiled before the statement, the total statement, complete statement itself. So at that time, think by yourself when you say, what shall I think? How many rows get back? That's not impossible. That's really impossible. So therefore, we do an estimate from 1 or 100. And that is the point, or that the problem, how we get all these wrong estimates. However, let's see how this will work with the interleaved execution. So now I run the same query again. Go for it. Now, when we look into the execution plan, here we are, you see that SQL Server has changed the execution plan. We were moving from a nested loop into a merge join, and the point here for this is that we now knew at compile time, that's important, at compile time, that we will get back 10,000 rows. Why? You see this when you follow the execution plan. Let me check this. Clear the data once again. Let me run this again. Don't see the interleaved. Could be that some are missing here because they are not showing the CPU pressure I have here. Watch live data on. Ricken will needs to run 3 times. Go. Leaved. Go. Wait. Yeah. Perfect. So here you can see that SQL Server now here has a different, let me see this. Yeah. Here is an interleaved execution status, and we now look to the query post execution plan for the table function. And look to this. SQL Server here is with the estimated number of rows completely in the line of the expected 1,000. So now we insert them into the cache. So, and now the statement is starting, and the post execution plan of this function returns the 10,000. So now it is completed, and now let's see, I need to go a little bit down. Statement here, it is completed, execution plan, it doesn't display as expected here. So here, so now, the key point here is that SQL Server, that sucks, that's not correct here. The display is not correct. Once again, I want to have the interleaved in between. So here, go for it. Because normally I would say, start with the state, here it is. So let's go. Interleaved execution status. And here we are with the plan. SQL Server after the compilation of the function, returns the correct number of rows. And then we can execute it with this known numbers, and SQL Server will slightly change the operation from a nested loop to a merge join, because we now have way more rows expected than with the previous versions. I have this here. Here you can see it in a little bit better. The key problem was that when the SQL statement was starting, the function was not evaluated at that time. It was coming later on. So that means that SQL Server, first of all, need to create a plan based on an estimate, which, by the way, was wrong. With the interleaved execution, SQL Server is a little bit different. Here you see how it works. For God's sake, I have a picture from this. You can see here in the green area that SQL Server is, before it starts the statement itself, it executes the multi-line table value function. So now, when you see the order here, first execute this. Now we know how many rows we have. And with this information, we can start with the execution of the previously compiled. Here you see the post-compilation show plan. That means SQL Server, now after we have investigated the number of the multi-line function, we now can do a pretty cool compilation of the complete query with this known value. I absolutely love this feature. And what you can do is, if you want to dive deeper into how interleaved execution will work, you have new extended events for monitoring. This is the list here, what you can see. And this is what I have shown in my, unfortunately, not so perfectly shown X event. Inline user-defined function, I promise then we are finished. Just only 15 minutes over, that's okay. Here comes we invite you to the expo hall. Oh, there is an Agnieszka, yeah. Thank you, Agnieszka. Hopefully I can close this. Okay, so the good thing, inline user-defined functions, and if you use inline user-defined functions, be happy, nothing has changed. Everything stayed the same because inline user-defined functions are used like typical select statements, like subqueries, like cross-apply. They are part of the set-based operations in a query. You can see it here. The only thing what you always need to take into consideration is that a user-defined function can never have multiple statements. You hand over the parameters, and the only thing what you say is it returns a table as return. And then there is your statement in it. And please, do not make the mistake to have user-defined functions inside your inline user-defined function. That could be a little bit nightmare. So here are a complete overview of the improvements by version. The Scala functions have been improved in 2019. I love this feature of inlining. If you are facing some problems with it, that can be because of now the correct estimates. I have one very close friend, an MVP from Vienna, Milos, I think you know him. They were facing some problems with this because they were using functions, especially to have a very small amount of estimated number of rows, because they wanted to force with this small number a nested loop operation. A good idea, but with the inlining, the query, which was formerly using a nested loop, then was taking more time with the hash or with the merge join operator. The multi-line table value function, they had some improvements over the year. In 2014, the estimated rows went up from 1 to 100. And then with 2017, that was, from my point of view, a great benefit too. It was the estimated rows returned. The estimated rows are exactly the number of rows which get returned back. So 15 minutes later and a few technical challenges later, we are done. My CPU is very hot and I see the keyboard melting down here. But I really hope that you all enjoyed what you have seen about functions. And I hope that you will now have a few more ideas how you can handle user-defined functions. And I would say I wish you a super cool and a pleasant time here in Wrocław, but the problem is it isn't. And I really hope that we can see next year back and then we again face to face. Thank you all, guys. Have a wonderful time. Enjoy it. Bye-bye.